Welcome, everyone. Today, we will be discussing an important yet often overlooked topic: how chemicals and fine particles in the air impact cancer risk. Presented by Emma Becker, Kai Nat Aklas, Devin Gamboa, and Adriel Farinas. I'm Devin Gamboa, and I'll be covering a basic introduction on chemicals and fine particles in the air. So, why is this important? Environmental factors are estimated to contribute to nearly 2/3 of cancer cases. That's a lot. While some of these exposures are work or lifestyle related, many of them are present in the air around us. We encounter these risks not just in industrial zones, but in everyday places: busy city streets, near construction sites, and even in our own homes. We often assume that because air pollution is out there, it's something distant or less immediate. But it's not. Whether it's fumes from a delivery truck, secondhand smoke, or even air fresheners that emit volatile compounds, we are constantly exposed to airborne substances that could potentially harm us. It doesn't take a major industrial disaster for these risks to add up. Fine particles and chemical pollutants can go unnoticed because we don't see them, but their effects can accumulate silently. When we think about cancer, we tend to focus on smoking or genetics, which are both valid. But we need to broaden that lens to include the environment around us: what we breathe, what we're surrounded by, and what's floating invisibly in the air. So, what exactly are fine particles, and what are some of the airborne chemicals linked to cancer? Firstly, fine particles are often referred to as PM 2.5. That stands for particulate matter that is 2.5 microns or smaller in diameter. To give you a sense of scale, that is about 30 times smaller than the width of a human hair. These particles are so small that we can't see them, but they are small enough to get deep into our lungs and from there, even our bloodstream. They come from various sources like vehicles, power plants, wildfires, and even activities like grilling food, leaf blowing, or using certain household products. Once in the body, the fine particles can trigger inflammation and damage tissues. Now for the airborne chemicals, several have been identified as known or probable carcinogens. Diesel exhaust particles have been clearly linked to lung cancer. Polycyclic aromatic hydrocarbons, or PAHs, result from burning things like coal, wood, and tobacco. They're associated with cancers of the lung, skin, and urinary system. Asbestos fibers, though more regulated now, are still present in older buildings and construction materials. They're directly linked to mesothelioma. I'm sure we've seen a commercial or two about asbestos. After that, we have the metals like arsenic, chromium, and nickel, which can be released from industrial activity and are also linked to cancer. We can be exposed to nickel through everyday items like jewelry, coins, or keys, while chromium, especially in its hexavalent toxic man-made form, may be present in industrial dust or older paints and coatings, especially near construction or manufacturing sites. I would say the important thing to understand is that these exposures aren't rare or unusual. They're in our everyday environment, and it makes it more vital to recognize and address them. The impact of these pollutants can be significant. Studies show that long-term exposure to fine particles and chemical pollutants increases the risk of developing various types of cancers, most notably lung cancer, also bladder cancer, kidney, and throat cancers. These pollutants can damage DNA directly or cause chronic inflammation, which increases mutation rates. Some chemicals may act over decades, accumulating damage until one cell finally transforms into a cancerous one. The risk can be even higher for children whose bodies are still developing and for elderly people who may have other health vulnerabilities already. There are things we can do. Living in an age where technology makes information so readily available, we can start by checking our local air quality index, or AQI. Websites like AirGov Now or even the iPhone weather app gives real-time air quality updates. On high pollution days, you could limit outdoor activities as much as you can, especially strenuous exercise. At home, we can put air purifiers with HEPA filters that can remove many of the particles we've discussed. You can try to ventilate your space regularly, and if you live near traffic or industrial area, consider sealing windows or using indoor plants that help filter air. Also, avoid smoking indoors and be mindful of things like burning candles or incense, which can increase the indoor pollution. These are small actions, but they can make a big difference over time, especially when combined with larger policy changes. Now that we've covered the basics on airborne particles and cancer risk, it's time to dive deeper into some peer-reviewed studies and the biological mechanisms. So, with that, I'll hand it off to Adriel for our next part. Thanks.
Hello everyone, my name is Adriel Farinas. Along with I will go over just what the latest science has to say regarding to connection between air pollution, in particular fine particles as well as chemicals, and even cancer. In my portion of the presentation, we will pay specific attention to novel research that assess the degrees of harm these pollutants cause, the precise type of cancer risk they provide, and the exact mechanisms that experts think are involved. Research peer-reviewed by bodies like the WHO, CDC, NIH, and IARC, almost known as Internal Agency for Research on Cancer, is the source of the information I'll present. This study is important because we are discussing pollution that affects everyone in the planet. That includes those who live in cities next to highways on or in industrial areas. We are just not simply discussing very infrequent exposures or quiet isolated instances. Just while we inhaling, there is a concern to us. There is the question of this slide. One of the major per- perpetrators is PM2.5, or particulate matter with diameters smaller than 2.5 micrometers. These particulates are fine and can travel as far as the bloodstream or deep within the lungs due to their extremely uh, minute size, detectably smaller than the weight of human air, about 30 times smaller. Carbon-based particles, organic chemicals, and heavy metals are the toxic compounds that comprise PM2.5. They are the result of our industrial activities, the burning of coal, traffic emission, and even the burning of biomass in some locations. Other pollutants include nitrogen dioxide, primarily from car exhaust, sulfur dioxide resulting from fossil fuel burning, ozone or tree created when other pollutants interact when exposed to the sun, and volatile organic compounds, including some recognized carcinogens. The threat isn't that these contaminants exist at all, but rather that they exist continuously everywhere all around the world and continue to exceed guidelines established by health organizations. Our lung cancer evidence is our greatest and most sound. Long-term PM2.5 exposure is strongly associated with an increased risk of lung cancer growth or death, as documented by extensive research. Based on sharp meta-analysis of 20 cohort studies, lung cancer growth rose by 14% for any 10 micrograms per cubic meter raise in PM 2.5. That matters, and especially so as long as this level is so much greater than it is in much of the city and industry. Two key research studies were especially impactful. The CPS2 studies by the American Cancer Association and the ESCAPE project in Europe. Both these studies give us robust evidence controller for confounding various variables such as occupational exposure, income, and smoking status. The interesting and key fact is that the effects also manifested among non-smokers, and this tells us it is most merely a secondary risk factor. It is an independent cancer cause backed by neurons, numerous studies. So, how does air pollution induce cancer? There are a couple of principal biological mechanisms identified by scientists. Number one, damage to DNA. The body undergoes oxidative stress caused by fire particles generating fire free radicals that are able to directly damage DNA strands. With inadequate repair of DNA damage, it can lead to mutations and carcinogens. Chronic inflammation. The body is kept in a constant low-grade inflammatory response from exposure to toxins over long periods, potentially damaging normal cell function and increasing the threat of cancer. And number three, epigenetic modification. Through gene regulation and not DNA itself, pollution may also influence gene expression. This happens through changes that to the elongation of telomeres, DNA methylation, and other mechanisms that may influence tumor suppression, as well as cell aging. Some research, especially from China, people provide significant information and data. One good example of this is the fact that individuals who are working in high-risk environments, for instance, the traffic officers, are at a greater possibilities of chromosomal harm and some DNA markers than workers who are working indoors, demonstrating a true evidence of the effects on day-to-day exposure. It is easy to observe that the most directly correlated is lung cancer. Later research also shown have established that air pollution is correlated to other cancers too. Research everywhere demonstrate correlation with lung cancer, bladder cancer, breast cancer, most notably among premenopausal women, colorectal and liver cancer, and leukemias and lymphomas. This is currently under investigation, but trends are alarming and these have been observed among various populations and regions globally. Based on an international study conducted, this is currently under investigation, but trends are alarming and these have been observed among various populations and regions globally. Based on an international study conducted and published in 2017, over 265,000 lung cancer cases were caused by PM2.5. Exposure during that year which is 40% of all the world's lung cancer, second only to smoking. In addition, the burden is higher among countries having high population, including part of South and East Asia, where PM 2.5 is 8 to 10 times higher than the set by the WHO. The World Health Organization, IARC, formally designated outdoor air pollution and, in addition, particle matter (PM) as a Group 1 carcinogens in 2013. This places them in the class along with radiation, asbestos, and tobacco smokers. This is generally a public health problem, not simply a medical issue, because no one can choose not to breathe air, not to breathe air, unlike with smoking, which is a personal decision. This is truly the reason that this research is so important. It provides copious data. Communities, governments, and healthcare providers need the data to advocate for clean energy transmissions, stricter air quality regulations, and public education. From a relevant medical standpoint, this delay implies that the full ecological exposure must be carefully discussed in precise relation to overall cancer prevention. I appreciate your attention, and follow will be my next teammate who's gonna discuss her part. Thank you for listening to me.
Hi everyone, my name is Kainat and I'll be walking you through part 3 of our presentation, the key research breakthrough on how chemicals and fine particles in the air are linked to cancer. These studies revealed just how deep the environmental impact goes, from molecular changes all the way to public health consequences. Let's start with PM 2.5, or particulate matter smaller than 2.5 micrometers. Because of their tiny size, these particles can penetrate deep into lung tissues and even into the bloodstream. The International Agency for Research on Cancer has classified PM 2.5 as a Group 1 carcinogen. According to the WHO, outdoor air pollution, especially fine particles like these, is linked to about 4 million deaths every year, with lung cancer being a major outcome. Long-term exposure especially increases the risk of non-small cell lung cancer, or NSCLC. Next up, diesel exhaust. It contains harmful compounds like PAHs, aka PAS, benzene, and soot particles, all of which are classified as carcinogenic. Both NIOSH and IARC list diesel engine exhaust as a known human carcinogen. Workers with chronic exposure, like miners and truck drivers, have been found to face a higher risk of lung and bladder cancers. Wildfire smoke is more than just a temporary air quality concern. It carries ultrafine particles and heavy metals that can cause oxidative stress in lung epithelial cells. A 2020 NIH study showed that repeated exposure to DNA strand breaks, and emerging research links this damage to epigenetic changes, which may drive long-term tumor formation even after the smoke clears. One of the most important breakthroughs came from a 2023 study in Nature. Researchers found that PM 2.5 can actually trigger lung cancer in non-smokers who carry dormant EGFR mutations. These tiny particles create an inflammatory microenvironment walking up pre-existing mutated cells and pushing them toward becoming cancerous. It's a huge shift in our understanding, showing that cancer doesn't always need new mutations to start, but can be activated by exposure. Benzene is a common air pollutant from vehicle emissions and tobacco smoke. Long-term exposure to benzene has been strongly linked to leukemia and other blood cancers. According to CDC and NIH, or aka NIH, benzene interferes with bone marrow function, damaging DNA and causing chromosomal abnormalities that lead to hematologic malignancies. This slide brings us into the realm of epigenetics, the molecular switches that turn genes on or off. Air pollutants have been shown to disrupt DNA methylation, histone modifications, and microRNA activity. These changes can alter the expression of oncogenes and tumor suppressor genes. Even after exposure ends, these epigenetic effects can persist, increasing cancer risk in the long run. Now, why does all of this matter? The real-world impact is huge. Urban and low-income communities often live in areas with the highest pollution levels, and that means greater cancer risk. Children in particular are more vulnerable. These studies reinforce the urgent need for stronger air quality regulations and public health protections across all populations. And these are the references used for this section, all from peer-reviewed sources and official health organizations. Thank you.
Part 4 Summary by Emma Becker. Thank you all for your attention today. Throughout this presentation, we've explored the significant role of air pollution plays in cancer development. We've discussed key pollutants, their sources, their biological impact, and the research backing these claims. So now, let's bring everything together and highlight the most important takeaways from our discussion. First, let's take a step back and look at the bigger picture. Why does this matter? Cancer is often thought of as a disease influenced primarily by genetic or lifestyle choices, like smoking or a poor diet. But research has shown that nearly 2/3 of all cancer cases are influenced by environmental factors, including air pollution. Fine particles and airborne carcinogens are major contributors to this risk. Studies from organizations like World Health Organization, which is also known as WHO, and the International Agency for Research on Cancer, also known as IARC, show that long-term exposure to pollutants can significantly increase cancer rates, even for non-smokers. This is why this is not just a hypothetical risk. In 2017 alone, over 265,000 lung cancer deaths were attributed to PM2.5 exposure. That's 14% of all lung cancer deaths worldwide. And this is not just lung cancer. Having exposure to air pollutants also have been linked to bladder, breast, liver, and even blood cancers such as leukemia. So why does this even matter? Because air pollution is something we are all exposed to every single day. Us understanding that there is a risk isn't just about the knowledge. It's about then taking further steps to protect ourselves and push for cleaner air policies. As you can see on the image on the right, this is the true magnitude of how small the air particles need to be in order to be deposited into our alveoli region lung, and mouth. Now, let's break down exactly how air pollution contributes to the cancer at the biological level. How does pollution even cause cancer? When we breathe in pollutants like PM2.5, nitrogen dioxide, sulfur dioxide, and the volatile organic compounds, also known as VOCs, these particles don't just stay in our lungs. The smallest ones, like PM2.5, are so tiny that they are less than 2.5 micrometers in diameter, that they can bypass our lung defenses, which can then enter into our bloodstream and travel onto our vital organs. Then, once they're inside our bodies, these pollutants can cause oxidative stress, which creates unstable molecules which lead to damage in our DNA. From this damage, air pollutants can then create a domino effect by triggering genetic mutations, which then lead to uncontrolled cell growth and cancer. It can also cause chronic inflammation, which is a process that promotes tumor development and disrupts genes that normally suppress tumors, making cancer even more likely. And this isn't just another theory. This is supported by extensive research. The American Cancer Society CPS2 study found that for every 10 microgram increase in PM2.5 per cubic meter, lung cancer risk increases by 14%. In 2023, a 2023 study published in Nature found that PM2.5 can activate pre-existing cancer mutations, meaning even people who have dormant cancer genes could develop tumors just from exposure to pollution. Because of this overwhelming evidence, in 2013, the International Agency for Research on Cancer, IARC, classified air pollution and PM2.5 as Group 1 carcinogens, meaning there is a conclusive proof that they cause cancer in humans. To the right, you can see the effects of air pollutants even on non-smoker lungs, as well as someone as young as 14 years old. You can also see on the image on the right that fine beach sands micro down to the PM2.5. Who's most at risk? Now, let's understand the risks. What can we do to protect ourselves? First, let's talk about people living in urban areas, how they face higher exposure due to vehicle emissions and industrial pollutants. Low-income communities are also higher at risk. They are disproportionately affected because they often live near factories, highways, or other major pollution sources. And children exposed to air toxins early in life are especially vulnerable because their lungs are still developing, just like you saw in the previous slide, making them more susceptible to long-term health effects. While we can't control all sources of air pollution, there are steps that we can take to minimize our risk. Monitoring your local air quality reports through websites like airnow.gov or even your iPhone weather app can help us avoid exposure on high pollution days. A perfect example of needing to check pollution levels was when the Los Angeles wildfires were happening, which sent massive amounts of fine particles in matter into the air, creating hazardous conditions even for healthy individuals. During those fires, air quality alerts warned residents to stay indoors due to dangerously high levels of PM2.5. Situations like this highlight why it's so important to check air quality regularly. Using air purifiers indoors can help filter out fine particles, improving air quality indoors. Avoiding outdoor exercise in high traffic areas can also reduce direct inhalation of pollutants. But beyond individual actions, policy matters. Research shows that countries with stricter air quality regulations have lower cancer rates over time by supporting policies that regulate industrial emission and vehicle pollution. We can reduce air pollution exposure for millions of people, ultimately preventing cancer and protecting public health. So, overall today, we have learned that what we breathe matters. The scientific evidence linking air pollution to cancer is clear, and it's not just about lung cancer. It affects multiple organs, increases inflammation, and even changes our DNA. While the problem is large, we are not powerless. By staying informed, taking precautions, and advocating for cleaner air, we can reduce our exposure and protect future generations from the same risks. Thank you all for your time, and we really appreciate your engagement throughout this discussion.